Download this code from codegive.com, link in the description below. Resolving PHP Composer Dependency Conflicts, a Doghouse Agency Guide. Composer is a powerful dependency manager for PHP. It allows you to declare the libraries your project depends on, and it will manage, install/update, them for you. However, when you introduce multiple dependencies, you may run into conflicts. These conflicts arise when different packages require different versions of the same dependency, and these versions are incompatible. This tutorial will provide a detailed guide on identifying, understanding, and resolving composer dependency conflicts, particularly focusing on strategies that a Doghouse agency, imagining we're a development firm, would employ to maintain code quality and efficiency. Understanding the root cause, the dependency tree. Before diving into solutions, it's critical to grasp the concept of the dependency tree. Imagine your project is the trunk of a tree. You require package A and package B. Package A, in turn, requires package C version 1.0. Package B also requires package C, but version 2.0. Now you have a conflict. Composer needs to decide which version of package C to install. Why conflicts occur? Incompatible version constraints. Packages declare their dependency requirements using version constraints, example 1.0, 2.0, 3.2. If these constraints overlap in ways that require incompatible versions, a conflict arises. Tight constraints. Overly restrictive version constraints in your dependencies force Composer to make tough choices, leading to more frequent conflicts. Circular dependencies. If two packages depend on each other, this can create a loop that Composer cannot resolve. While rare, it's important to be aware of. Root package conflicts. Your project's composer.json file itself might have incompatible requirements with one or more of the dependencies. Platform requirements. Conflicts can also arise due to conflicting PHP extensions or versions required by different packages. Identifying composer conflicts, the diagnosis. The first step in resolving a conflict is identifying it. Composer is generally good at alerting you to conflicts during installation or updates. 1. Composer install or composer update output. The most common way to discover conflicts is when running composer install or composer update. Composer will often halt with an error message like this, simplified for clarity. This message clearly states that package A needs package/package C version 1.x, while package B needs package/package C version 2.x. Composer cannot satisfy both requirements simultaneously. 2. Composer why and composer why not commands. These are invaluable tools for understanding why a package is, or isn't, installed in your project. Composer why package name. This command shows you which packages are requiring a specific package. This might output something like: this confirms our earlier diagnosis. Composer why not package name version. This command tells you why a specific version of a package cannot be installed. This is helpful when you're trying to force a particular version. The output might reveal that package A requires package/package C version 1.x, making version 2.0 incompatible. 3. Composer depends command. While less directly helpful in conflict resolution, composer depends is useful for understanding a package's entire dependency tree. It lists all the packages a given package depends on, directly and indirectly. Doghouse agency approach, prioritization and communication. As a hypothetical doghouse agency, we would approach conflict resolution methodically, emphasizing collaboration and clear communication. 1. Risk assessment ****. Impact analysis ***. Before making any changes, we'd analyze the potential impact of resolving the conflict in different ways. What functionality depends on package A and package B? Which is more critical to the project? Are there known compatibility issues between different versions of package/package C? Business requirements ***. We'd discuss with the client, or project stakeholders, whether there are any constraints on which dependencies must be used due to business requirements, example a security compliance requirement mandating a specific version. 2. Communication and collaboration ***. Team discussion ***. Bring the conflict to the team. Leverage the collective knowledge to brainstorm potential solutions and identify potential pitfalls. Dependency owners, if applicable. If package A or package B are internal packages maintained by different teams within the agency, or the client's organization, we would proactively communicate the conflict and collaborate on solutions. This might involve suggesting changes to the dependencies composer.json file. Resolving the conflict, practical strategies. Now, let's look at the actual techniques for resolving dependency conflicts. 1. Updating dependencies, the first line of defense. Often, the easiest solution is to update your dependencies to their latest versions. Newer versions might have relaxed constraints or be compatible with each other. If the problem is that package A and package B require different minor versions of package/package C, for instance *1.0 and *1.1, updating might bring them both to a compatible version. 2. Loosening version constraints, cautiously. If updating doesn't solve the problem, you might consider loosening the version constraints in your project's composer.json file. This allows Composer more flexibility in choosing versions. However, this should be done with extreme caution. Identify the constraint *, determine which package is causing the tight constraint on the conflicting dependency. You can use Composer Y to help. Assess the risk before changing a constraint, thoroughly research the compatibility between the original version and the version you're considering allowing. Read change logs and look for potential breaking changes. Test thoroughly after loosening a constraint, run extensive tests to ensure that all functionality still works as expected. Example Let's say our composer.json looks like this. And package A requires package/package C *1.0, while package B requires package/package C *2.0. After research, you determine that package A might be compatible with package/package C version 2.x. You could modify your composer.json temporarily. This is for testing. This will basically restrict package/package C from being installed lower than version 2. Afterwards you should run Composer update, and thoroughly test your application to see if package/package A still work as expected. Important * never blindly loosen constraints without proper testing. You could introduce unexpected behavior or break your application. 3. Using conflict and replace in composer.json, advanced. The conflict and replace sections in composer.json are powerful but should be used with care. Conflict as shown in the previous example, this section explicitly declares packages that are incompatible with your project. This can be useful when you know that a particular package or version is problematic. This tells Composer that your project is incompatible with versions of package/problematic package older than 1.2.0. Composer will refuse to install those versions. Replace this section allows you to replace a package with another package or a specific version of the same package. This is often used when a package is deprecated or you want to force the use of a different implementation. It effectively tells Composer to ignore the original package and use the replacement instead. Caveats **** using conflict and replace can have significant impacts on your dependencies. Make sure you understand the consequences before using them. *** These directives are most effective when you control the composer.json of a package being developed. 4. Platform requirements, platform in composer.json. Sometimes, conflicts arise due to different platform requirements, example PHP version, extensions. You can specify your project's platform requirements in the platform section of composer.json. This tells Composer to assume that your environment meets these requirements, even if it can't directly verify them. This is particularly useful in containerized environments where you precisely control the runtime. However, it's crucial that these requirements actually are met in your deployment environment. Lying to Composer can lead to runtime errors. 5. Using -ignore platform recs and -ignore platform recs equals extintl***. This command line option is for ignoring the platform requirements. It can be useful for testing in environments that do not perfectly match the target system. Note that this is best for testing. Ignoring specific platform requirements. 6. Forking and modifying dependencies, the last resort. If all other options fail, you might consider forking a dependency and modifying its composer.json file to relax its version constraints. This is a drastic measure and should only be considered as a last resort, as it introduces significant maintenance overhead. **Fork the repository ** Create your own fork of the affected dependency on a platform like GitHub. ** Modify composer.json * Adjust the version constraints in the forked repository's composer.json to be more compatible with your project's needs. *Update your project * In your project's composer.json, specify your forked repository as a repository source and require the modified version of the dependency. You'll need to configure Composer to use the forked repository using the repositories section in your composer.json. Important * Forking introduces a maintenance burden. You'll need to keep your fork up to date with the original repository and reapply your modifications as needed. Consider contributing your changes back to the original repository if they're generally applicable. Doghouse Agency Best Practices: Prevention is better than cure. As a responsible agency, we would also focus on preventing conflicts in the first place. Maintain dependencies regularly. Keep your dependencies up to date with the latest versions. This reduces the likelihood of encountering conflicts due to outdated requirements. Use broad version constraints judiciously. While loosening constraints can sometimes resolve conflicts, be mindful of the potential for introducing compatibility issues. Use semantic versioning, SEMVer, principles when defining constraints. For example, 1.0 allows updates within the 1.x branch but prevents automatic upgrades to 2.0, which might contain breaking changes. Automated testing. Implement a robust automated testing suite, unit tests, integration tests, end-to-end tests, to catch any regressions introduced by dependency updates or constraint changes. Dependency analysis tools. Consider using tools that can analyze your project's dependencies and identify potential conflicts before they become problems. There are commercial and open source tools that can assist with this. Code reviews. During code reviews, pay attention to changes in dependencies and version constraints. Challenge developers to justify any tight constraints and ensure that the impact of dependency changes is properly assessed. Package selection before introducing a new dependency, carefully evaluate its reputation, maintenance status, and dependency tree. Choose packages that are well maintained and have a history of compatibility. Code example, demonstrating a conflict and resolution. Let's create a simplified example to demonstrate a conflict and how to resolve it. Directory structure composer.json index.php Now, run composer install. You might get a conflict like this, depending on the specific version. Here, Symfony/console in the 2.x line requires dependencies that needs psr/log 1.0, while monologue/monologue needs psr/log version 1.1 or greater. Resolution *. 1. Update dependencies *. The most common solution is to update your dependency to the latest version. Let's update Symfony/console to a newer version. Change composer.json to. Now rerun composer update. This might resolve the issue. Doghouse agency summary *. Prioritize understanding *. Don't just blindly apply fixes. Invest time in understanding the root cause of the conflict. Communicate and collaborate. Keep your team and stakeholders informed. Test rigorously. Every change related to dependency resolution must be thoroughly tested. Document your solutions. Keep a record of the conflicts you encounter and the solutions you implement. This will help you avoid similar problems in the future. Automate where possible. Automate the process of dependency analysis, testing, and deployment. By following these guidelines, a hypothetical Doghouse agency can effectively manage composer dependencies, minimize conflicts, and ensure the stability and maintainability of its PHP projects. Remember, a proactive and methodical approach is key to success.